We have a really neat prime number question here. I think a good shout is to just start by writing down the primes. Now, you might just know these, or you might have to figure them out. One way of figuring them out is just to work your way up and then just think, is it a multiple of anything or not? So 4 is, but 5 isn't. You have to have obviously a feel for this. 7 is okay, then 8 and 9, 10 don't work, but 11 is okay. You can ignore all the even numbers to be fair, so we can just go for the odd numbers at this point. So 15, no, that's 3 times 5. 17, yes. 19, yes. They're not in the times tables. 21 is 3 times 7, 23. 25, no. 27, no. 29, 31, and so on. Okay, so it's not quite sieving out numbers as you go, but there is something called Eratosthenes sieve, which I would recommend looking up. But here I'm just kind of just working my way up, and maybe you got your own strategy for writing some of them down, but that's my one. Right, now we're trying to find 4 prime numbers and the smallest possible sum of these. So I think a good idea is just to start by adding up the 4 smallest prime numbers and see what we get. And we're going to get 17, which is prime. But then the triple is going to have to be the 3, 5, and the 7, because otherwise it's going to be even. When you add 2 odds, you're going to get an even. So if you then add that to 2, you're still going to get an even. So the triple, yeah, will have to be these, and that gives 15, which is not prime. So 2, 3, 5, 7 doesn't work. But it does give some insight into this, because if you add up 4 odd numbers, you're going to get an even number. So 2 must be one of the numbers. To ensure, I'm going to call it the quadruple is odd. Now we know that the sum can't be 17, so actually that leaves us like maybe looking at these ones here. And one other little thing that I noticed is that the quadruple and triple will differ by 2. Because when we use the triple, we're going to have to use the 3 odd numbers. Because odd plus odd plus odd is odd, whereas odd plus even is even. So I should maybe add that to my... Okay, so the quadruple and triple will differ by 2, so they will actually be a twin prime pair. Twin primes are prime numbers that are pair that just differ by 2. It's exactly what I just said, really. So 17 and 19 are a twin prime pair. So this could be a possibility. Actually, see, so that means I don't need to try for 23, because there's no way that like 23 doesn't have a twin prime pair. So if 17 and 19 fail, then 29 and 31 are going to be the next 2 that I try. Speed things up slightly. Okay, so what actually I can do is seek a triple that adds to 17, because if I get that 17, then I'm guaranteed to get the 19 when I add the 2 on. So I'm going to seek a triple that sums to 17. Now, we had that 3 plus 5 plus 7 is 15, so we could use that as the basis for this. I'm just going to write out again. Actually, remember, I don't have 2. Okay, so this added to 15. Now, there's no other prime that I can add that is just 2 more. So this is not possible. not possible to achieve. You could maybe write down there's no prime number that's two more than either 3, 5, or 7. Okay, I'm not going to write that down here, but yeah, actually that's a good idea. So we can abandon this straight away, and therefore the next attempt is going to be to get 29. Okay, so let me write this down again. 13. Right, remember I have to add 3 of them on. So all right, can we get 29? Well, 3, 7, and 19. That will work. Also 5, 7, and 17. There's actually 2 ways to do this. They will sum to 29 as well. So overall, this works. I've argued that we have to have a twin prime pair, and I hope you're happy with that, because when I add the 2 on, I also need a prime. So we looked at 17 and 19, we ruled it out. We then can ignore 23 completely because there's no way that you could get a twin prime pair. We looked at 29, 31, managed to get it in 2 different ways, in fact. So um, basically, we're going to have 2, 3, 7, and 19, or 2, 5, 7, 17. Now, do these both work? Because actually, I've forgotten one thing, and that was that I also have to have um, the sum of some pair being a prime. Okay, so I've got 2 plus 3 is 5. This works. And over here, 2 plus 5 is 7. This one works. I've got the triple, 3 plus 7 plus 19 is 29. And the exact same thing happens over here. Is it 5 plus 7 plus 17 is 29. And finally, we've got the triple. If I'm just adding a 2 on, I'm going to get 31. So both work. But the key thing is that the smallest sum is going to be 31. Okay, really nice question on primes to end things. And yeah, well done on this challenge.